Hi, it's Bruce, and welcome once again to the Rocky Mountain Lab. And I'm doing part two, follow up on the construction of this bipolar adjustable power supply. Um, we're capable of doing 0 to 25 volts and up to an amp. But what I found when I was testing the board is that the heat sink, there was no heat sinks provided with the board. And as a result, the board could not handle the load that it was rated for. They didn't tell you that in the instructions. They just sold it to you as being capable, which it isn't. So I don't recommend this supply, but what I've had to do, I had to replace one of the LM317s. It was a type that mounted to the board, and it wouldn't. It's actually like the 377 that's over here. You can see I put a small heatsink on the top of it. Actually super glued it there because I didn't have any glue that was thermal compound, but this works good. But in order to dissipate the heat from these heat sinks, I needed a fan. So even though I didn't want to have to do it, I bought a fan, and then I had to try and kludge a way of mounting it within the unit. Since it's a two-piece assembly where the top snaps on, I could not mount the upper part of the fan to the top of the box. So I could only mount it at the base. So I did that. And we'll turn this thing on so you get a look at the outside of it here. You can see the two mounting screws. You can see the series of inlet holes that I drilled to allow airflow in. And the same thing on the top, so when the two are together, you kind of get the idea. Same thing on the opposite side, so we've got cross ventilation. And we're blowing right across the two heat sinks. So we'll try and keep that cool. I don't know how long this board will last for me. We'll see. It might last forever, and then again, it might, buy the farm a couple hours into its use if I try to push it at 80%, which is what I'll do it at. I won't go more than 0.8 amps on this thing. I think it's just too kludgy. Instead of buying this particular power supply, I don't recommend that one now. It had good specs, but don't buy it. If you wanted to buy one for about $6 and some cents, I bought a kit, and it is the same kind of power supply. It's an LM317 and 377, I think it is, or 337 to be for the negative. But this comes with a really nice board, really well-made fiberglass board. Comes with two decent heat sinks for the two units. And because it's a kit, I was able to upgrade it. I went and upgraded the regulators to the higher voltage types, and I also increased the voltage capacity of the capacitors. So I can drive this thing up to like, I don't know, 30 some odd volts DC. And if I do burn out that power supply that's in there, what will happen is I'll replace that entire board in there with this board. Part of the reason I can do that is that this board has the power supply built into it as well as the regulators. And I had to add that power supply on this other one, which is why I had to have that bottom board. So that whole board will go out. This board will come in. It's even more compact. I'll place it in this sort of a direction so I get a nice cross ventilation by the heat sinks, and my problem would be solved. So finally, I feel confident that I have something here, both now and in the future, that I'll be using. I'll snap the top back on, we'll get a good look at it, and then we'll say goodbye. Okay, so we've got the unit back together, and that means that from the side we can now see the perforations for the fan mounting screws. The upper two screws were never drilled through all the way because we can't attach to that upper part of the shelf, otherwise never be able to open it again. Couldn't do it anyway. So opposite side we drilled the same pattern for the cross through ventilation, and if we extend the wire stand, there we go. Nice unit. And it varies no more than 1/10 of a volt at 0.8, from 0 to 0.8 amps output on both positive and negative side. I should probably test it to see how long I can run at 0.8 amps before the unit kicks out on overheat. We'll see. Okay, well, we've been running about 20 minutes now, 15 volts at a half an amp. We started out at 15 volts unloaded, and we raised it up to a half an amp, and it still held the 15 volts. So we've got 0 volts of loss, at least to the 1/10 of a volt, due to loading anywhere in the circuit. And we're drawing a half an amp, and it's been, like I said, about 20 minutes. We're capable of running it this long at this amperage. When I tried to run it 0.3 of an amp higher, which would be 80% of its rated load, it failed in about 5 minutes. It shut down on thermal overload. So that's the way it looks. Okay, well, we've connected up to the negative side, and we've been running the last 20 minutes, 15 volts at a half an amp, negative, and we're doing just fine. The load unit, the heatsink is warming up. I expect to see that fan kick on somewhere along the way. But it looks like we're capable of running at a half an amp, which is 50% of the rated value of the kit. And that's only because we threw heat sinks onto the unit, and we had to replace one of the regulators. The long and short of it is I will probably replace that board and go ahead and install this new kit board, which I highly recommend if you're going to do something like this. Much better unit, much better heat transfer capability. You got the power supply built on it. They give you everything you need. It's in a smaller unit size. And I'm still recommending that you get a fan and get that cross ventilation going on in there, but I suspect you'd be able to run at least the rated value, and I believe that's at least an amp, maybe an amp and a half on this unit. Take a look for it. Ran about 650, came out of Hong Kong, probably, but was using Canadian funds, so there you go. Thanks for listening, and hope you listen to the recommendations and have some fun out there. Bye.